Hello everyone! Today we're going to solve the hard-hitting problem of winning 649 and what the optimal play would be. Yeah. So how long will it actually take us before we win? And this is win the jackpot. I'm not super interested in the sub goals where you get like 3 numbers matching. I honestly don't know how to play 649. But I do know the concept behind it. We choose 6 numbers between 1 and 49. There's no repeated numbers within that set. And then the lottery will choose 6 numbers. And if they all match, we win. And then that's good, I guess. So we can apply our scientific method to this, where we could mathematically guess. No. Statistically figure out how many, on average, plays we would have to do before we win the jackpot. It is not that complicated. It's moderately complicated. Enough that I don't feel like teaching you stats and showing you here. I'm just going to do the simulation. There's some interesting problems here because we have a set of numbers from 1 to 69, and we have to be able to choose some numbers from it. So we'll talk a little bit more about the science after we start the simulation. I want to be able to write code that will give me a random set between 1 and 69 of 6 numbers. I want to write a function that will compare 2 different sets of numbers and see if they're the same. And we'll see why that's a problem. And we can start with that. Let's do it. Hey, look, a blank piece of paper. It's so nice. Import random. Random. And first, I want to create my numbers. Obviously, I'm going to sit here and type out all these numbers. No, I'm not going to do that. I'm going to say range from 1 to 69. 1 and up to none, not including 70. Because if we want to go up to 69, we have to go to there. And I'm going to write a function that is going to choose 6 of them for me. Or has Python solved this for me? I could write this code, and I want to have no duplicates. And it's actually an interesting function to write. I encourage you to try writing a function that would choose 6 numbers out of a set of n. But maybe I can just flip over to this tab, and we know that random.choice exists, and we know that we can choose 1 item. Can we choose n items? Well, yes, we can. Random.choices population, we can actually give it weights, and we give it a k. This is using a kind of funny syntax of key value pairs. It's always key value pairs. This k is what I'm really interested in because I want to choose k is equal to 6. But because we are programmers, what if we change it to the Lotto Max, which you chooses 7 numbers? I don't really know, but that's my understanding. Num numbers? Oh boy, naming constants is hard. Sample? I don't know. Selections. Num selections. Number of selections is 6. 649. And I could actually even say max num. If I want to be really fancy and say that it's 69, because it's Lotto 649, and here I'd say max num plus 1, because we go up to and not including max num in range. And then we have everything set up, which is pretty cool. Okay, def. Compare 2 sets. First of all, we have a lot of things we need to start on. This should all work. Now we actually have numbers. How does random.choices work? Choices. I can pass it numbers. And I think it's going to give me 1 by default. But I can also give it a key value pair back and say I want 6. Choices, plural. Now I get 6 back. Okay. That's good. Let's keep this. we're going to call this a set. I can't use set. Set's a reserved keyword. Nums is equal to this. This is just me hacking. So I have that. Now I'm going to make a nums2, and I'm going to flip two of them. The last two. 18, 50. Okay, so now I have nums. I have nums2. Those would be a match in no uncertain ways. Can I do this? Oh, sorry. I definitely can do that. Can I do this? Will this be return true or false? We want it to return true. It returns false. We'll do an element by element comparison, but its element by element will break when it says 18 and 50 switched. Okay, well, how do we see if they're the same? Is there a built-in function that can help us here? Ordered? Oh boy. I'm gonna look at my built-in functions. Oh, is it just, oh, it's part of the nums dot tab, not append, sort. Is that gonna work for me? So sweet. Now they're sorted. Nums2. And you notice that it did it in place, which is actually interesting. That is something we don't get out of strings. Now nums is equal to nums2. Now it's true. So if we sort them, then it will put them in ascending order, and then we can reliably match them using the equals equal signs. So that sounds like a function because there's actually a lot of things going on there. Def are same, nums, not nums, list 1 and list 2. There's no good names here. Return, and we couldn't do this in one line, and that's maybe okay. Dot sort is equal to list. Ooh, no, that's not gonna work. What did list1 dot sort actually return to us? Oh, I have to change this to nums. Out. Well, I'll have to look at my variable explorer. Out is none. So I couldn't do this in one line. And this will actually destroy my data. Remember that we're passing things as reference with a pointer. This destroys our list or reorders our list. So we might want, if we didn't want to destroy our data set, we would actually have to rethink this problem and do it a different way. I don't mind just calling sort because I don't want this video to be half an hour and I'm already not on my way to make it. So we'll see. For everyone, it's bad. It's not bad. It's okay. Sort both lists. And then are they the same? Oh, I need to put spaces. Pretty code is good code. Good. Well, yeah, we haven't chosen any random sets. Okay. So now we need to do some trials. So we're going to play def do lottery. And we are going to choose a random number. Because you can actually do that. You just go to your local lottery kiosk and say, I'd like to play the 649, and they'll give you random numbers. You can choose some numbers, and then they can give you those numbers. Most people just choose random numbers because it's the same odds. So this is going to be do lottery, and this I'm going to make a doc string, and it'll return true if we won. Returns, I'll actually use this, true if we won. So basically, it returns false. So bitter. I'm sorry. Okay, make two sets. Ours is equal to random dot choices from our numbers, and we want to choose num selections. Yes, let me do that. And then winner is equal to the same thing. I can just copy and paste that. And then we will return if they are the same. R's and winner. And you can see that I actually really don't care that I've reordered these because I'm never going to look at them again. This function will exit, and then we're done. Play. So I'm going to do the lottery. This is much cheaper than doing it in real life. Int object is not callable. That is probably true. Oh, yeah, that's helpful. Click on the one that's actually an R code, which is this one. You can see my pointer. It's line 24. Random choices, numbers. You get to see me debug something. I wonder if it's unhappy about the range thing. Let's try this again. I had tried this on the side to make sure that it would work. Let's just copy this. Which one does it think is an int? Oh, let's talk about documentation. If you have something like this, and you can see that the error is inside of a different function, look back at this. You can pass in arguments as placeholders using key value pairs, or in which order. In this class, we generally just use the order because that is more general to all programming languages. Python lets us get away with more. So I'm passing in without k equals, so it's putting in weights is equal to num selections. And it's trying to do something with that code. And if I jump back, you can see that, yeah, it's doing something with weights here. And this is not my code. It's not unreadable, but it's in the random library. You can see up here, I'm gonna switch over to this view. You can see up here that, yeah, that is not our code. So don't debug not your code. We didn't use it right. K is equal to. And notice that I copy and pasted and propagated an error. That is a very Rob problem. And there we go. Let's do some lottery. Let's win some money. False. Now, if I was not a smart person, what I would do is count these, and well, maybe I would hire a summer student to run this and count how many times they did it. Def. Play to win. So my goal here is to run this n times until I win. And what I want to return is how many plays I had to make until I won. Count plays until win. Return that count. What kind of loop is this? It's a while loop. Certainly not a for loop. We cannot use a for loop here because we don't know how many times it's going to run. So count is equal to 1. I could win the first time. Done is equal to do lottery. Remember, this is going to return true once we win. While not done, do lottery again. And increment our count. Last time I did this, I didn't return my count. I should probably do that. And then I'm going to print play to win. This is pay to win, am I right? Am I right, everyone? Okay. I'm going to pause the video. It is 12:17. I will see you sometime. It is now 12:24. We have still not won. Remember from my slide, we actually even said we can time events with import time. So let's add that so we can stop our program by hitting this beautiful red button here. Stop. Stop. Import time. Usually we do our imports first. And then we want to time it. Start time is equal to time.time, which is seconds from January 1st, 1970, aka the beginning of time. And then we can print how long it took by saying print. I'll actually calculate it. Total time is equal to time.time, which will have changed because this took forever, minus the start time. So this will give larger number minus smaller number. This will be a positive number in seconds. Print took this many seconds. And this is going to be a raw floating point number, and that's okay. Format total time. There we go. I'm going to hit play. I think I'm going to go for lunch because this will probably take quite a while. Pause. It is now 12:27. After looking at my program, there might be a bug. Funny thing about random programs, it's very hard to know if it's still going or not properly. But I probably should capture the if we won. Save. Run. Oh, I have to stop it first. Stop. Run it with my new, now actually probably successful program. And it's going to happen in 5 seconds. If not, I'll pause it again. 5, 4, 3, 2, 1. See you in magical time. After a nice little lunch, took 453 seconds, which is how many minutes? Divided by 60, right? 7 minutes. We could also calculate how many times it. Oh yeah, it took this many tries, which visually is very difficult to parse out. 86 million tries to win. It's a tax on people who are bad at math. So that's how we do that, and do some debugging apparently, and that's okay. For science, well, what if we, instead of choosing a new number every time, choose one number and keep on playing that? Will our numbers change? And null hypothesis? No. Hypothesis 1? Yes. Well, it shouldn't be our hypothesis 1. We actually know that's not the case. But we can put it to the test. And that is our hypothesis, even though we are expecting that it'll not be that. So we can shape scientific experiments around these random runs. If we wanted to compare 2 different sets, what we would want to do is multiple runs of each, get a standard deviation, and actually compare the different populations. This is Stats 1000 stuff, and we can do that. And we can make these numbers ourselves and compare them, which is compelling. So the summary is, set up the experiment, debug it, repeat as many trials as you need to actually get your result that you want. I hope you're having a good day, and I'll talk to you later.